beginning of this, you should already know how to do. Okay, take a look. So, rate of change, what is it? You know. What is the rate of change? Slope. Okay, good. So this is the slope. Okay, technically, rate of change, is the change in y over the change in x. So you might have seen this in your, I don't know, science class, delta y over delta x. Remember, that means the change in y over the change in x. Good? Okay, now slope is also rise over run. Okay, or y2 minus y1, x2 minus x1. Now, we are going to rewrite that formula to make it more calculus-y.
Oh, great.
Okay, so all that we're going to do is f of b minus f of a over b minus a. Are we good that that's the same? F of b is the y value at b. F of a is the y value at a. You're subtracting the y's on the top, x's on the bottom. Good? Okay, so average rate of change, I'm going to abbreviate as AROC. So if you ever see that, that stands for average rate of change. And that is the slope of a line through 2 points. Okay, every slope you've ever taken up until calculus is through 2 points. So when your teacher was calling it slope, really it was the average slope. Okay? So this is a secant line slope. This is what I mean by that. Look at your little graph that I found off Google. Okay, so it says draw a secant line from -2 to 1. So -2 is here, 1 is here. Then the secant line would connect those 2 points. Oops, I kind of did it weird, but you get the idea. Now, from there, you're going to take the secant line and you're going to calculate the slope of it. So there are 2 ways for you to do it. The easier way is rise over run, but I'm going to have you write it out with the formula. So it would be f of 1 minus f of -2 over 1 minus -2. Good so far? Okay, what's f of 1? What's the y value? 3 minus, what's f of -2? -3 over 1 minus -2. Okay, what do we get on top? Bottom? 6 divided by 3 is 2. Could have given you that in Algebra 1. You probably could have done it. Okay, go to Part B. We want to secant lines through -3 too. So, -3 is here. 2 is, we're going to estimate it here. I know it's not exactly there, but just pretend. Okay, then draw your secant line through those 2 points. Okay, and then we're going to calculate the slope. So you would do f of 2. This is actually, it should be -3 to 2, if you'll fix that. I made it really quick during lunch, so that should be a 2. Okay, so I do f of 2 minus f of -3 over 2 minus -3. Then from there, f of 2 is how high we're estimating? 1. F of -3 is 0. And then 2 minus -3 is really 2 plus 3, which is 5. So your slope is a fifth. We're all good on that? Okay. So a derivative is the slope, look right here. A derivative is the slope of a line that is tangent to the graph at that x value. So for example, f prime of 3 is the slope of the line tangent to the graph at 3. F prime of -2 is the slope of the line tangent to the graph at -2. So, draw a tangent line through x equals 1. Now, let's see what you remember from geometry. If I gave you a circle, let's just review here. Okay, a secant line hits how many places? 2. So this is a secant line. A tangent line should only hit at how many points? 1. So if I draw, let's say I want to go through this point, that's a tangent line. Okay, or if I wanted to be maybe over here, that would be a tangent line. So a tangent line only hits your graph at that one dot. So for example, if I wanted to draw the tangent line at 1, I would come to 1 on the graph, which is right here. And then what you're going to do is you're going to try to fit a line along the curve of the graph so that it matches the same slope. So here I have negative tangent slopes, positive tangent slopes. When I get to the top of this dot right here, okay, at 1, my graph is flat. That's a tangent slope. And if that's a tangent slope at 1, okay, and it's flat across like that, what slope does that have? 0. So I'm going to put f prime of 1 equals 0 because it's horizontal. Okay, go down to letter D. Next, we're going to do a tangent line at -3. So, go to -3 on the graph. That's right here. And I'm going to draw as best as I can, okay, a line that's going to match the same slope as my graph at 3. So I drew it right here. And then I'm going to estimate the slope at that point by finding the slope of that line. So my pretty points, if you had McDaniel, that's what she calls them, okay, from here to here would be down 1, 2, 3, 4 over 1. So I'm going to say that f prime at -3 is about -4. Now, obviously these aren't exact, they're estimations, okay, but you get the idea. Okay, last one we're doing is x at 1. So go to the graph at 1. Oh wait, hold on, we already did 1. Let's do -3. Oh wait, we already did -3. Do 2. Okay, go to 2 on the graph, and I want you to kind of perfectly draw a line, okay, that's going to match the steepness of the graph at that point. That would be represented by f prime at 2. So I'm going to come down to my graph here. I want f prime of 2. And then I'm going to count the rise over run of that line segment that I just drew. So if I'm here, it looks like 1, 2, 3, 4 over 1, so it's -4. Get the idea? Okay, now a function is called differentiable. You've seen this word maybe on a couple of things. Okay, it says a function is differentiable if there is a tangent line with a defined slope. So positive slopes are defined, negative slopes are defined, 0 slopes are defined. What slope is not defined? Do you remember? A vertical. Very good. So turn the page. So a graph will not be differentiable at C if one of 3 things happens. The first one is if f prime is undefined, which means that you have a vertical tangent. Okay, I'm going to give you 2 examples of that. The first one, okay, do you know what the cubic root graph looks like? Okay, it looks like this. In the middle, at this exact dot right here, okay, my graph is vertical. And so at that point, you would say the graph is not differentiable. My slope is vertical, which means that it's undefined, which means it's not differentiable. Another picture of what that could look like is draw a circle for me. Okay, so let's say we have a circle. Where would my slope be undefined on a circle? The sides. So over here, I have a vertical tangent. Over here, I have a vertical tangent. So here and here, I would be not differentiable. So I'm just going to put not diff, you get the idea. Okay, but if your slope is vertical, I don't have a slope because it's undefined. That's the whole problem. Okay? Now, the other option for a graph to be undefined, okay, read right here, is when the slopes from either side of that point are not the case, in which case f prime does not exist. And I'll show you 2 examples of that. The first one, draw the absolute value graph for me. Okay, so it looks like this. Okay, the reason you cannot draw a tangent line on this graph is because there's no way to put a line on it where it's going to perfectly match both sides. On this side, my slope is negative. Okay, we'll put negative slope. On this side, I have a positive slope. So there's no way for me to fit a line on that where it's going to perfectly lay against the curve. Your graph has to be smooth for you to draw a tangent line. So I'm going to put here, not smooth, oops, smooth, so no tangent line. And if I don't even have a tangent line, I can't find the slope of it. So anytime that you have an abrupt change in slope, like at a corner, okay, we're going to call this a corner, you will not be differentiable. The other type of graph that this same thing happens in is at a cusp. So draw kind of like a wave. Okay, this is called a cusp. And it has the exact same issue as the corner, it's just when the sides are curved. So if you have a cusp in the graph, on this side I have a positive slope, on this side I have a negative slope, and there's no way for me to perfectly draw a line on that to where it can be tangent to both sides. Does that make sense? Okay, here's what I mean by that. Let me try one more time drawing it. Okay, if I were to put my tangent line, pretend that's not there, I'd be like, oh, my tangent line is here, right? But then if I cover up this side, what's my tangent line doing? Here. No? Yes? Okay. So the problem is that since you don't have a smooth graph, if I cover up this side, it looks like my tangent's that way. If I cover it this way, my tangent's that way. That's a problem, okay? So you have no tangent line at a cusp or corner. That means your f prime dne. Okay, the third type is if your graph is not continuous. If you don't like that word, it's not connected. Okay, so if you have a break in the graph, you can't do a tangent line on it. Okay, for example, let's say you had this. Okay, there's no way for me to draw a tangent line touching both sides if they're not even connected to begin with. So, not connected, no tangent line, not continuous, not differentiable. Now, the one distinction I want to point out to you is that if it's a vertical line, you can put undefined. But if it's a cusp, corner, or a disconnect, you would put DNE. Okay? So it's DNE for this guy, and it's DNE for this guy. But for this one, you would put undefined. Okay? Now, on the AP test, usually they're not going to care which one you put. Okay? Alright, so come down to your bottom little graph. Okay, we're going to do a little easy practice. Okay, so take a look at your picture. Draw the average rate of change from 0 to 4. How many points should you be passing between? 2. 1 at 0, 1 at 4. Then count the slope between those 2 points. So if I'm going from 0 to 4, 1, 2, 3, 1, 2, 3, 4, what's my slope? Negative 3 over 4. I do not need you to show the work on these, okay? Next one, we're going from negative 4 to 2. Negative 4 is here. 2 is here. Oh wait, hold on, negative 4 to negative 2. I read that wrong, sorry. 2 is down here for negative. Connect your dots. And then count the slope. What is the average rate of change connecting the line from negative 4 to negative 2?
Negative 2.
Good. 1, 2, 3, 4, 1, 2. Negative 4 over 2 reduces to negative 2. Okay, last one like that. Negative 2 to 1. Draw your tangent slope in. Negative 2 is here, this same point. 1 is here. Connect your lines with a line segment, or connect your dots with a line segment, then find the slope. So if I'm counting here, 1, 2, 3, 4, 1, 2, 3, 4 thirds. Easy? Okay, next one I want is f prime at -2. So f prime means the slope of the tangent line that only touches the graph once. So if I want to only touch the graph at -2, that's right here, I'm going to draw my tangent line there. Because I can only touch the curve at that one point. And if I only touch it there and I draw that line in, what's its slope? 0, because it's horizontal. Next one, I want f prime at 0. F prime at 0 is here. Can I draw a tangent line on that guy? No. What do I say about the slope then? DNE, because I have a cusp. If either side is curved, it's a cusp, not a corner. Okay? Next one, f prime at 1. 1 is here. Can I draw a tangent line on that? Sure, it'd look like that. What's the slope of that guy? 0. Next, I want f prime at 3. Look at 3. Can I draw a tangent line on that guy? No, that's a what? Corner, so it'd be DNE. Last one, I want it at 3.5. 3.5 is here. Can I draw a tangent line in there? Sure. There to there. And if I look at that line, what's the slope of that? 1, 2, 3 over 1, -3. Get the idea? No? Question? So the main difference you should have in your head is an average rate of change is the slope through 2 points. A derivative is the slope through 1 point. Okay, so turn the page. Okay, next thing I want you to do is we're going to draw a couple of sets of slopes. So the first thing I want you to do is draw the slope of the tangent line through 0. Draw that onto your picture. Okay? Draw the tangent line through 0. So it should be sitting alongside the graph so that it only touches the graph at 0. So 0 is here. Say my tangent line maybe is like that. That's f prime at 0. Good so far? Okay, now whatever the slope of that is, that's what f prime is. Okay, next I want you to draw the secant line through 0, 3. So 0 is here, 3 is here. So my tangent line is pretty steep, right? Okay, really, 3 is not even on the graph, so I can't even really draw that. Okay, next draw the secant line through 0, 2, and then through 0, 1. And I guess I already did it through 2, so let's go 0, 1 next. 0, 1 would be here. Next one I want you to draw, since we couldn't really put 3 on there, is do 0 to a half. So if I went to a half, that'd be like right there. What do you notice about the slopes as your points get closer together? So this is my real slope. My orange slope is way too steep, right? My purple slope gets a little bit closer. Then when I went to that little half point, it was even closer to the real slope of the line, right? So what you can do is, so let's fill in this question here. What do you notice about the secant lines? Their slope gets closer to f prime of 0 as the second point is closer to 0. So as my points get closer together, my slope gets closer to the real slope at that point. So we can use limits, that's this blank right here. Okay, you can use a limit to algebraically find this value. Okay, and I'm going to tell you the definition right now. So, as this point, this second point, gets closer and closer, this slope is going to eventually match this guy exactly. But my points have to be really, really, really close together. So, write the limit of f of x minus f of a over x minus a. Now, what is that already the formula for? That's the slope formula. What are my 2 points? X and a, right? What I want to do to make those closer together is I'm going to make x approach a. So this is the definition of the slope of the line at A. So, definition of slope of tangent at x equals A. Okay, so let's look at an example. Okay, you're going to literally use that exact formula to find the slope now by hand instead of just kind of looking at the picture. Okay, so first one says find the slope of the graph at -1. Well, then I want f prime of -1. What's my A value? What's in A's spot? -1. Okay, so let's do our formula. It should be the limit as x approaches A. What's my A? -1 of f of x minus f of A over x minus A. So far, so good? Oh, wait, hold on. Those shouldn't be A's. What should they be? -1s. So we're plugging in. Our A is now a -1. Okay, so let's plug in our values. What is f of x? What is our function that we want the slope of? X squared. And then I need to find what f of -1 is. So f of -1 will just be -1 squared, which is what? 1 over x minus -1 is really an x plus 1. Are we good with that? And you already know how to do that limit. So you take your definition, you plug in all of your little crap things, whatever, and now you're just going to fix it. What are your two choices? We could do L'Hopital's rule, or we could factor cancel. I'm going to pick factor cancel just because it's easier, but you could also use L'Hopital's rule. How does the top of that break down? Okay, good. So x approaching -1 of x plus 1, x minus 1 over x plus 1. The x plus 1's do what? Cancel out. All that's left is a -1. I'm going to plug that in. What is -1 minus 1 more? -2. What that means is that on this graph of x squared, the slope of the line at -1 is -2. So go onto your graph at -1. And I want you to draw for me a slope of -2. So I'm going to count up 2 over 1, up 2 over 1, and then connect the dots. And you should see that your line is perfectly tangent if you pick a slope of -2. It only touches at that one point, and it lays along the curve perfectly to be tangent. Okay, now we're going to do the same thing at 3. So I want f of 3. Limit. What is x approaching then in the definition? 3, because that's my A value. And then I'm going to do f of x minus f of 3 over x minus 3. Okay, now let's plug our crap in and turn it into an equation. So what is f of x still? X squared. And what is f of 3 if I plug it in? F of 3 is 3 squared, which is 9. And then I look at that and I'm like, oh, I can fix that, right? Factor the top, cancel out the term on the bottom, and then plug in what's left over. So if I do the limit as x approaches 3, break the top down into a plus 3 and a minus 3, so that my minus 3's can cross out, and then I'll plug in 3 to what's left over. So take your 3, jump it in. What's 3 plus 3? 6. Okay, so I want you to go to the graph at 3. So 3 is here. And then I want you to draw a slope of 6 through that point. So 1, 2, 3, 4, 5, 6, backwards 1, and then draw it in. And that would be your perfect tangent slope to touch the graph at 3, whatever it is, 9, and then keep going and never touch it again. Okay? Now, here's where the easy part comes in. You could have done this derivative without the limit altogether. You have to know the definition for AP, but you can do this using your derivative rules. So, watch. I'll show you what I mean. My function is f of x. What is f prime of x?
2x.
You already know this. Derivative is 2x. Now plug in negative 1. What do you get? What did we get when we did it the limit way? Negative 2. All that work, but we could have just taken the derivative, plugged it in. Okay, now, what would f prime of 3 be? Well, plug in a 2 here, times 3. 2 times 3 is 6. What did we get when we did it the long definition way? Still 6. So, the limit definition is where the derivative comes from, but obviously it's way longer. So you don't have to do it that way, but you should know, you should recognize it in case it's on the AP test, which it probably will be. Okay, last page, turn over. Last page. Oh no, 2 pages? Blast. Okay, look at the next one. We have a different graph now. It's 2x squared plus 1. We want it at x equals 2. So put f prime of 2 equals. And then we're going to do our definition. Limit x approach 2 of f of x minus f of 2 over x minus 2. So we're doing it the definition way first, then we'll check it with the derivative rules. Okay, first step, what is my f of x for me to substitute? Okay, so I'm going to have the limit as x approaches 2 of 2x squared plus 1 minus. Then I need to find f of 2. How do I find that? I'll just plug it in. So that'd be 2 times 2 squared plus 1. 2 squared is, follow PEMDAS, that'd be 4 times 2 is 8. 8 plus 1 is 9. So I'm plugging in a 9 right there over x minus 2. Simplify the top of that guy. What's 1 minus 9? So I have the limit as x approaches 2 of 2x squared minus 8. Is that factorable? Yeah. What can I take out from the top? 2. And when the 2 comes out, what does it leave behind? X squared minus 4, which is a perfect square. So then break it down one more time. It'd be 2 x plus 2 x minus 2 over x minus 2. And then from there, what can I do once I break that top down? Cancel out the term from the bottom. So my minus 2's are gone. That's all that's left. Then what do I do with my 2? Whoop, plug it in, right? So 2 plus 2 in the middle is 4. 4 times 2 is 8. So what that means is that if you went to the graph at 2, which is right here, and you perfectly drew in a slope of 8, that would be tangent to your graph. Okay, now let's do it for the bottom one. So we're doing f prime of 0 this time. F of x minus f of 0 over x minus 0. Okay, what's f of x we said? Be 2x squared plus 1, right? Minus. Then f of 0, I'm plugging in 0 to that. What is 2 times 0 squared plus 1? 1. On bottom, x minus 0 is really just x. What happens with the 1's on top? Oh, I forgot to write my limit. Oops. So then now what's left over is the limit of 2x squared over x as x approaches 0. I don't even have to really factor that. What's going to happen if I have an x squared on top and an x squared on bottom? These guys can cancel and leave me with just a 2x. And if x is approaching 0 on 2x, what do I get when I plug that in? 0. Now look at your graph. At 0, does it make sense that my answer came out to be 0? Look at your tangent line. At that point, what's the slope? 0. Okay? Now let's take the derivative, make sure that they match the answers we got the long way. So if f of x is 2x squared plus 1, what's the derivative of that? 4x, what about the plus 1? Gone. Let's find f prime of 2, that was the first value we found. Well, if I plug in 4x, plug in a 2, that's now in 8, right? 4 times 2 is 8. Is that what we got when we did it the long way? Yes. Okay, then let's say I want f prime of 0. What would I get? 4 times 0 is 0. And that's what we got the long way as well. Okay, so the question is, can I just do the derivative? Answer is most of the time yes. Sometimes on the AP test, though, they'll ask you to work it out the long way. So that's why I just want you to see it. Now, will they do it much? No. But if you're really wanting to understand everything on the AP test, that's one thing that's sometimes on there. Okay, now the bottom one, just for the sake of time, if I wanted f prime of 2, what happens in the graph at 2?
Oh, it's the corner.
It's a corner. What's the limit going to come out to be? DNE. Okay, because there's a corner. Okay, I was going to make you work it out, but we will skip it. Okay? Last page. Okay, last one. This one you just have a table. You already pretty much know how to do this. Look at part B. Oh, and they're all lettered B. Great. Okay, so it says using appropriate units, find the average rate of change. What does average rate of change mean? Slope over 0 to 2. Do you know how to do that? Yeah, what would you do? H of 2 minus H of 0 over 2 minus 0. So if it's an average rate of change, you're literally just finding the slope. It's a fancy way to say it, but you already know how to do it. Now, go down to B. What if I ask you to estimate f prime of 3? What you're going to do is you're going to take the average rate of change of the interval that 3 fits in. So if I want 3, where does that fit between? Then I'd find the average rate of change on 2 to 4. Because that's the smallest interval that 3 will fit in. It won't give me the exact slope, but it will give me an estimate. So you'd have h of 4, h of 2, 4 minus 2. Okay, go down to letter B. Average rate of change, they have to give you 2 values. They gave us from 4 to 8. So we do h of 8 minus h of 4 over 8 minus 4. But then for an instantaneous rate of change, you have to pick the interval where that number fits. So if I want h prime of 9, where would that fit between? 8 to 10. So you'd have to do the average rate of change from 8 to 10. Because 9 is between 8 and 10 seconds. So if you have a table, that's how you would do it. Okay? Do you feel confused? Do you understand? Still confused or a little bit? Okay, here are the big takeaways. Average rate of change, how many points do you need? 2. For an instantaneous rate of change, how many points? 1. On a graph, a tangent line goes through 1 point and it's the derivative, versus a secant line goes through 2 and it's the average rate of change. That's the main thing. Yeah? And then you can do the derivative using the limit or taking the derivative and plugging it in. Great.
Ebenezer, you straight, bro?
Hey, take a picture of his answers and I'll just sign it, and then you write them in. That way you're not that late.
Wait, are you getting it right now?
Hey, let's go.
I haven't finished my ASAP college. I stayed up to 2 a.m. and then I woke up to 5 a.m. just to try to do it. I started at 5.
Okay, thanks. Hey, just keep that safe.
Okay, yes.
She probably knows at
I
this
go
point.
all the way to psychology.
I don't even have my sheet.
Your college sheet?
Yes.
I think I lost it. I believe.
When is it due? Tomorrow?
I got it tomorrow. He said he
Oh wait, no, that is different. You showed me the wrong sheet. You showed me the.
Oh, I showed you the option.
Yes.
Sorry.
Oh shoot, I'm gonna get it. Oh no, I found it.
Does it matter what number I am?
No.
Just do 3. Okay.
I'm gonna have to. What?
Yeah, I'll sign yours and then you can just copy your answers.
Named it for me.
Are you in band too? I had a bunch of kids in orchestra last year.
They're Asian, right?
Well, I had Sydney Needham, I guess the guy's daughter. And then I had Jessica Ma, Jasmine Tran. I had Eileen.
Jasmine and Jessica told me to take AB, not BC.
They told you what? To take
Not
AB?
Take AB, not BC. And they were 1 and 2, so I was like, yeah.
Yeah. Last year, so many of the top all picked AB.
You know. They're so
I know.
ticklish.
They have an in and out.
Yes, that's what I'm working at. Look, there's no in and out.
How much are they?
They're like, because like we get gifts every time that we have accident free. So it's like what, 2 months accident free. So we get a water bottle. We have to choose from a water bottle, 25.
Oh wait, someone else works at In and Out.
Seth, maybe, I don't know. He's not a
Oh wait, are you at which one are you at?
LBJ Coy.
Okay, I saw somebody up there who was who?
Adele maybe?
No, he's up there too?
Yeah, but he goes to Emory
I
now.
want to say it was Faye Afioma.
Afamia. I got her that
You did? Oh, I saw her up there the last time I was there. I was like, oh.